Are you ready? 21 hard SAT math problems. You've read the title. It's going to be a long video. So get whatever energy drinks that you have right now. Let's get started with question number one. In triangle XYZ, angle Y is a right angle. The measure of angle X is 34 degrees, and the length of XY is 40. If the area in square units of triangle XYZ can be represented as K tan 34, where K is a constant, what is the value of K? There's only one question on the SAT that has tangent in it, and it's this one. And it's the same type of question every single time because the SAT loves to repeat questions, just with different numbers. The solution to this is you take the side length, you square it, and you divide it by 2. This works every single time. I wanted to put this question as the first question that we did because there's an easy trick for this. You don't even need to solve the problem. Just do this every single time and it works. So 40 squared divided by 2. Let's take out Desmos because we're going to need that. Okay, 40 squared divided by 2. 800. That's our answer. You do not need to know why this trick works. I mean, you can totally solve this problem on your own and figure out why the trick works, but it works every time. That's all you need to know. You don't need to know why it works. You just need to know that it works. So just take the side length squared and divide by 2. There's only one side length. The other ones are degree measures. So it's very easy to spot this side length. It's the only question that has tangent in it. Let's move on. Okay, the table shows 3 values of x and their corresponding values of y, where s is a constant. There is a linear relationship between x and y. Which of the following equations represents this relationship? Okay, here's what we need to do. I'm going to show you the easiest ways to solve these questions. Now, not all of these questions are going to have like super easy tricks like this, where it's like side length squared divided by 2. But a lot of these are going to have very easy solutions that you can like just remember on the test and immediately start implementing. So for this, all I want you to do is pick the most simple point out of the 3. And since I like positive numbers, I like the 3s comma negative 35. I guess the y value is still negative, so not really completely positive, but this is our point. If we zoom out, we can move around the slider for s, and the point moves around as well. That's the first step. So for questions like these, whenever you get a table and also like the 4 equations of a line, just put the point first, and then we want to graph every single line. And I'll show you why. Because when we graph every single line, we'll see that there's only one line that contains this point at every single value of s. What we can do here, we can do a little trick, edit list, and then duplicate, just to save ourselves a ton of time. Oh, I duplicated the wrong thing. This one. So we can do this over here, minus 9. Okay, let's move on to the next one. And y. Okay. And once you type everything into Desmos, just do a quick glance, just double check if you typed everything correctly. Please, I've seen so many students, very smart students, mess up typing things into Desmos. This is not where you should be missing points because there's a very correctable error. And it takes like no time to correct. That's what I meant. Okay, now when we move around S, we see that there's only one line, which is this line right here. I can select it. I guess I can't. That has S on it at every single value of S. You make sure that it's not like set to 1, because see when it's set to 1, there are two lines that have S on it. We need to figure out what this line is. And if we unhighlight each of these lines, we see that D is our answer. See how we numbered everything A, B, C, D? So when we unhighlight D, we see that that is the line that we are talking about. That's our answer. That's the easiest way to do this question that I know of. I'm basically going to try to show you the easiest ways for all of these questions as we go. For two acute angles, angle A, by the way, if you press edit list, you can delete all. It's on the left. For two acute angles, angle A and angle B, cosine A equals sine B. The measures in degrees of angle A and angle B are 9x plus 10 and 48 plus 5x, respectively. So what is the value of x? Here's the thing. If you ever see this on the SAT, cosine A equals sine B, or sine A equals cosine B, it doesn't matter. Here's what you want to do. We do not set these equal to each other. We do not do that. A plus B equals 90. This is what you need to memorize. If you ever see this, immediately write this. And since this is A, this is B, what we can do is 9x plus 10 plus 48 plus 5x, because this is A and B, equals 90. We can put all of this into Desmos because it's one variable. Whenever you have an equation with one variable, put it into Desmos. Do not do it by hand. You get a calculator on the test, so use it. Okay, here's the problem. This is a decimal. I mean, it's an irrational decimal, or irrational fraction. Here's what we want to do. Change this into A. Change this into A. And then change the equal sign into a tilde. Now, you don't have to make it A. It works with any variable other than X and or Y. But if you press A right here, and then press this fraction button, you get 16 over 7, right? So it simplifies the fraction for you. The problem is if you put the, let me duplicate this and I'll show you, if we do it with the X, there is a function on Desmos where you can export these points. The problem is when you do this export button, let me highlight that for you guys. Do you see that? If we export it, it cuts it short because Desmos can't put in infinity decimals there, right? So exporting it doesn't work. The only thing that works is doing this tilde thing, like replacing the equal sign with a tilde, and then using the fraction button on the variable alone. So then we get x equals 16 over 7. This is our answer to this question. We do not set a and b equal to each other. We do a plus b equals 90. All right, I placed this problem strategically after the last one because it's the same exact thing here, except the opposite. If you ever see a plus b equals 90 or x plus y equals 90 or two angles that are complementary, that means that the sine of the first angle equals the cosine of the second. And also the cosine of the first angle is equal to the sine of the second. So these two are true. I need you to memorize this identity. Basically, if you ever see this, that means the angles are complementary. Same thing if you see this. What does that mean? So if angle x and y add up to 90 degrees, that means sine x equals cosine y. So we can immediately answer choice A, because cosine y is going to equal sine x. I'm sorry, I didn't even read the question. I should have read the question first. But I think you get the point because the last question was pretty similar. Okay, next one. The table gives the volume of two similar cylinders. If the radius of a cylinder A is 6 centimeters, what is the value of R minus S? And then we're given a little table, which is pretty neat. I actually wrote these questions. I don't know why I'm surprised. Okay, and we're given the volume and surface area formula. We're actually not given this reference sheet on the SAT, but by the way, I wrote these questions. I I modeled them very similar to the SAT because the SAT loves repeating these questions just with different numbers. So I thought I'd do the same. I mean, it's the best type of practice for the actual SAT, just to take SAT questions and just switch out the numbers because that's what they do on their tests. Okay, how do we solve this? Well, here's the thing. This is actually a scale factor question. Now, scale factor questions are one of the most complex types of questions. So I'm going to try to explain this as best as I can. But if I don't do a good job, let me know in the comments and I'll make a full video on scale factor alone. Again, this is one of the most complex concepts. Okay, first thing that we want to do is we want to go into calculator and do 108,000 divided by 864. And we get 125. Now, what is this 125? Well, if we took the volume of cylinder B, so I'm going to label that V of B, divided by the volume of cylinder A, we get 125. That means the volume of cylinder B is 125 times larger than the volume of cylinder A. Here's how I'm going to explain this. If we have two cubes, right? Now, for cubes, all of the edges are the exact same. So let's say every single edge on cube A is 2, and every single edge on cube B is 4. Even though all of the sides on cube B are 2 times as large, let me use a different example. Let's say this is 6. So every side on cube B is 3 times as large as cube A. All scale factor means is this. It's how many times larger each of the side lengths of the bigger shape is to the smaller shape. So in this case, the scale factor for this example is 3 because each of the side lengths are 3 times as big. All you need to know is that because the scale factor is 3, the surface area of cube B to the surface area of cube A is going to be 3 squared, which is 9, meaning the surface area of cube B is going to be 9 times as large as the surface area of cube A, even though the sides are only 3 times as large. Now, the volume of cube B divided by the volume of cube A is going to be 3 cubed, which is 27. So the volume of cube B is 27 times as large, even though the side lengths are only 3 times as large. And you can even do it. You can figure out the surface areas of each of these, and you'll see that the surface area of B is 9 times as large. And you'll see if you find the volumes of each, you'll see that the volumes are 27 times as large because that's a scale factor cubed. That's what you need to know to solve scale factor questions. What we want to do is, since we're dividing the volumes, we know that let's go back to the cylinders, right? So the volume of cylinder B is 125 times larger, meaning the scale factor has to be the cube root of 125. Do you remember when we had the example where it was 27? The volume of the cubes was 27 times of a difference. That was 3 cubed. So to find the scale factor, we need to take the multiple of the volume and take the cube root. Functions, go all the way down. Let's press this. Cube root of 125 is 5. 5 is our scale factor. From here, this is a tricky one. What we want to do is figure out pi r squared h equals 864 pi. The reason why we want to do all of this is because in order to find the surface area, we first need to find the height, because that's in the surface area formula. Okay, so we can divide pi from both sides. We know we're given that the radius is 6, because it says that the radius of cylinder A is 6. So 6 squared h equals 864. What is 864 divided by 36? So the height is 24. Now we're given the radius is 6 and the height is 24. We have everything we need to find the surface area of cylinder A. Okay, so the volume, not the volume, 2. And if you type in pi, you get pi. 6 squared. Yep. Plus 2 pi times 6 times 24. Okay. And this 1130.97 whatever is equal to s pi. So in order to find out what s is alone, because we want r minus s, we have to divide both sides by pi. Basically, we have to take this entire thing and just divide by pi. Okay, 360. S equals 360. Perfect. From here, we can actually shortcut the entire process, because if you know that r pi is the surface area of cylinder B, we can use the scale factor to immediately find out what it is. Since the scale factor is 5, then cylinder B is going to have a surface area that's 5 squared is large, because surface area is area, it's squared. So it's R is basically going to equal S times 5 squared. So we can just do it on the same line, 5 squared, which is equal to 9,000. Since we want R minus S, we just do this minus 360. It was a very long process, and I know the scale factor concept might be pretty new and or confusing to a lot of you guys. And I think I can definitely do a better job explaining it in an in-depth video. We just don't have a ton of time right now. We have 21 questions to go over. So let me know if you want to see a video like that. There are going to be 2 more scale factor questions as we go through these next, I don't know, 17 or so questions. However many are left. The area of a triangle is equal to x squared square inches. The base of the triangle is 21 minus x inches, and the height is 4 minus x inches. Which of the following could be the value of x? Okay. Whenever you see a geometry question, you have to draw it out. Actually, that triangle is too perfect. There. Okay. The area of this triangle is equal to x squared. Once you get a geometry question, just start labeling everything. The base of the triangle is 21 minus x. This is this entire base. And then the height, you have to draw a line that's perpendicular to the base, because that's the definition of a height. It's 4 minus x. Okay, this is not that bad of a question. because the area of any triangle is equal to 1/2 base times height. And then we can start replacing everything. So we know the area is x squared. We know the base is 21 minus x. And this 4 minus x. Just do this on Desmos, right? So x squared equals, whoa, 1/2 times 21 minus x times, whoa. I should look at what I'm typing as I'm typing it. This reminds me of middle school when I was learning touch typing. I would be looking at my keyboard instead of looking at the screen. But okay, so here's what we get. And you might think, okay, so 3 is our answer, but it's nowhere here. Whenever you graph anything on Desmos, even if you're just plotting a solution to an equation like we are doing right now, make sure you zoom out a few times, right? Otherwise, you're not going to see everything. You want to make sure you're either seeing the graph or seeing everything. So since 3 is not here, our answer is going to be -28. And then you might ask, but how can x be a negative number? I thought this was supposed to be like triangles. X can be a negative number because only the area, the base, and the triangle, like the triangle's height, have to be positive numbers, right? You can only have a positive base, height, and area. And if you plug in -28 for x for the area, the base, and the height, you get positive numbers every single time. So the x can be negative as long as the area, base, and height are positive. Next one. For the exponential function, g, the value of g of 3 is q, where q is a constant. Which of the following equivalent forms of the function g shows the value of q as the coefficient or base? Okay, these questions are typically worded a lot more complicated than they need to be. So whenever you see this phrase, coefficient or the base, it's always asking the same question. Just ignore everything that it says in the paragraph and just look at this, what they want you to plug in. If it says y-intercept, obviously you plug in 0 for x because the y-intercept is when x is 0. But if it says g of 3, then obviously you plug in 3 for x. And we want to do that for every single one. I'll show you why. So for answer choice A, g of 3 is equal to 27 times 1.2 to the power 6, because 3 plus 3 is 6. Let's go to the next one, 64 times 1.2 to the power 2. G of 3 equals 172 to the power 1.2 to the power 3. D is g of 3 equals 1036 times 1.2 to the power 0. 3 minus 3 is 0, meaning this turns into 1. This entire thing does not turn into 1. Only this. Anything to the power 0 is 1. So this is really 1036 times 1, which is 1036. Now, you have to check, like the correct answer is going to be the one that's equal to the coefficient or base. Meaning, if we go to answer choice A, what is the coefficient? 27. What is the base? 1.2. Is this 27 or 1.2? No, it's 27 times 1.2 to the power 6. So it is not equal to 27. It is not equal to 1.2. Hopefully this is making sense on why this question is like actually really easy. Okay, coefficient for B is 64, base is 1.2. Is this 64 or 1.2? No, it's not 64, it's not 1.2. And I think you already found the answer by now, because this is not 172, this is not 1.2 either. And even though this is not 1.2, because that's what the base is, it says coefficient or the base. But this is definitely equal to 1036. That's what we found. So answer choice D is the correct one. It is actually a significantly more simple problem than you think. It's just worded very long. Like some of these questions that I've seen on the SAT that have this phrase are just way too long. And they do that on purpose. Just letting you know. So don't fall into the trick, that's all. The positive number A is 520% of the number B, and A is 65% of the number C. If C is P% of B, which of the following is the closest to the value of P? Here's what we want to do. Let's set up some equations. This is the easiest way to solve this, honestly. We just have to get used to whenever we see these percents and like these variables, we just have to get used to setting up equations. Is the most predictable, is the easiest way to solve this. Is very clear when you start solving questions, percent questions like this on like what your next step is. So A, let's just translate this into an equation, letter for letter, word for word. A goes down to A. Is always equal sign. 520%. Anytime you see percent, just take the number and divide it by 100. Please don't write 5.2. I know you know that 520% is 5.2. But I don't need you to do that because A, Desmos can do that for you, and B, I've seen so many students make the mistake of, let's say, you get 0.3%. I've seen so many students write 0.3 instead of writing 0.003. Anytime you see percent, just do the same thing over 100. It doesn't matter what it is. A percent is A over 100. P percent is P over 100. N squared plus 1%. N squared plus 1 over 100. Anytime you see percent is just over 100. You will never make a mistake that way. The SAT can never get you to make that mistake. I've been traumatized by watching my students make that. So that's exactly what I tell them. Just put it over 100 and they stop making that mistake forever after they change that one thing. Okay, of always means multiplication. So multiplied by the number B, and then this part, A is 65%. So A is 65% of the number C. And the final equation that we want is C is P% of B. P%, again, P over 100 of B. I think from here, a lot of you guys will have the right next step of just setting these two equal to each other. Okay, but what do we do from here? Actually, let me switch this. So it looks like the equation that we want down here. Okay, what we want to do from here, multiply the numbers out of C, right? Because if we want it to look like this, then C is isolated, so we have to isolate C. Okay, C equals 520 over 65. Don't simplify this yet, right? We don't need to do that. We just need to make sure that we're, Desmos can do all the math all at once, all at the end. For right now, just focus on doing the work right because we need to solve for P. That's the end goal. So these two equations now look very similar. The only difference is that it's this and this. So you might think that, oh, this is P, right? No. 520 over 65 would get you the wrong answer. 65, that's 8. This is the wrong answer. P%, if C is P% of B, then that means C equals P over 100 times B. That means P over 100 equals 520 over 65. Let's write this over here, 520 over 65. And what I do is I wouldn't even multiply the 100 to the other side. I'm that lazy. I just want Desmos to calculate this entire thing for me by using one variable other than X or Y. And instead of the equal sign, use the tilde. Okay, 800. Perfect. Let's move on. Let f of x equal 42 times a over 21 to the power x plus b plus c. How many times does the graph of the given function in the xy plane cross the x-axis, where a, b, and c are integer constants, such that a is greater than 21, b is less than 0, and c is less than b? I think a lot of students, their first intuition is to put this all into Desmos, and I like that. Do that. I will say, whenever you see a question, um, don't put it into Desmos every single time. Like, what I would recommend is just sit there and think about it for like 10 seconds on if there's a faster solution, um, like by hand, or if there's a faster solution just by, moving some of the variables around or something. But in this case, it's definitely the right idea to just put it into Desmos. Equals 42. And yes, there is a faster solution by hand, but it's very conceptual. You have to understand that for an exponential function, this is basically the limit as x approaches negative infinity. Right now, we can just do this on Desmos, just make it real simple, right? We don't need to know any of that. Okay. Oh man. All right. Put parentheses here. Okay. And then what we do from here is we just create sliders for all of them. And we make sure that these are matching the constraints. So if this says it's greater than 21, has to be greater than 21. Let's do 22 to 30, step one, doesn't matter what the step is. And then B has to be less than 0. So let's do 0. You want to try to do this process as fast as possible. And actually, let's make this -1. What am I doing? Okay, -2 to 20. Oh, -20. My bad. Okay. And you see that whenever B is between 0 and C, whenever A is greater than 22 or 21, and whenever C is less than B, the graph only intersects the x-axis at one point and only one point, right? So once, that's your answer. Okay, wonderful. Let's move on. All right. Whenever you see an equation of a circle, before we even start reading the question, whenever you see an equation of the circle, you should jump in joy because these are just free points. I'm serious. In the xy plane, the graph of the given equation is a circle. If this circle is inscribed in a square, what is the perimeter of the square? Okay, well, let's draw a circle and then let's draw a square. Okay, I think that should be, there we go, perfect. Wow, that's beautiful. X squared plus 10x plus y squared plus 12y. Okay, the reason that we graph this after we draw it, because drawing is always first on these geometry questions, always draw it out. I'm serious, always. But then we graph it is because on Desmos, and I don't know why this is even allowed, Oh, what the heck? I'm glad I caught that. There we go. I mean, what Desmos does is that anytime you graph a circle, it gives you the topmost and bottommost points. It does not give you the leftmost and rightmost points. These are intercepts, the x-intercepts, not the rightmost and leftmost points. So select the top one, select the bottom one, and here's what we're going to do. We're going to do a equals, and then on the bottom, we're going to do b equals, and we're going to do distance, T-A-N-C-E, a comma b. And I think that you understand that this is basically the diameter of the circle. So the diameter of the circle is 56 units. Now, all like the distance function does on Desmos is the distance formula. If you don't know what that is, you don't need to know. All that means is that it finds the distance between 2 points. So in this case, if we found the diameter and we're looking for the perimeter of the square, then the diameter is basically exactly the same length as the side length of the square. So finding the perimeter, we just take this diameter and we multiply it by 4. And what we can do is we can do it on the same line, 224. So the perimeter equals 224 because it's just 4 times the diameter. Next one, delete all. A right circular cone has a volume of 2,592 pi cubic inches, and the area of its base is 324 square inches. What is the slant height in inches of this cone? All right, that's the first thing that we do every single time. Volume equals, and then we start labeling everything. It's not enough just to draw the diagram. I did not label this one though, so that's on me. I should have labeled the diameter. Let's see, 324 pi. What is the slant height? So the slant height is the edge. That's the length of the edge. Whenever you see slant height, I always want you to think right triangle or Pythagorean theorem. Every time you see slant height, think Pythagorean theorem. Why? Because for any cone, come on, be a nice oval. I guess it's not cooperating, whatever. For any cone, the height is going to be perpendicular to the base. And also the radius and the height form a right triangle with the slant height. We typically label the slant height as L because I guess S would stand for like side or something, and you don't want to get confused with your variables. So if your slant height is L, your radius is this. It's the first leg of the triangle. Your height is the second leg. And that means R squared plus H squared equals L squared. Whenever you see slant height, they always test you on this, on the SAT, every single time. Okay. So the two things that we need to find the slant height are the radius and the height. That's it. How do we find the radius? Take the base area, 324 pi, and set it equal to pi r squared, because the area of a base of a cone is a circle. Divide pi from both sides. So r is just square root of 324. R is 18. Okay, the volume is 2592 pi. And the volume of any like pyramid, of any cone, of anything, any shape, like any 3D shape that like goes up to a certain point, is always the base area, so the area of this circle, times height times 1/3. And you can totally look at the reference sheet and like check this, but I don't have the reference sheet pulled up. And I'm also a SET math tutor, so I should have this stuff memorized, right? So 1/3 base area, which I would label as a big B, times height equals 2592 pi. All right. And we know that the base area is the 324 pi. So 324 pi times h 2592 pi. And here, honestly, I would just put in this entire equation. H equals 24. Okay, so we got R equals 18, H equals 24. To solve this, we go back to the Pythagorean theorem and we start from here. So do you see how like the next steps illuminated as we use like the original R squared plus H squared equals L squared? Because in order to find the slant height, we needed the R and the H. So if you're having trouble on these SAT questions, what I would recommend is you just try one step at a time and let the next steps illuminate as you go. Basically, at every step, ask yourself, why can't I solve this right now? What information is missing for me to immediately get the answer? Why can't we solve for L squared right now? Because we don't have R and H. Okay, L equals 30. I think that says 3, 4, 5, triple. Okay, so L equals 30. Perfect. The slant height is 30. Let's move on. A quadratic function models the height in feet of an object above the ground in terms of time in seconds after the object was launched. According to the model, the object was launched from a height of 10 feet and reached its maximum height of 1,099 feet in 33 seconds after it was launched. Based on the model, what was the height in feet of the object 44 seconds after it was launched? Okay. My throat is parched. Oh man. Okay. Energy drinks taste so bad, but they're just so addictive. Okay. There's only one type of question on the SAT that starts with that's actually a lie. Let me put it this way. There's one type of question on the SAT that starts with a quadratic function and is also a long word problem. So if you see a long word problem that starts with the phrase a quadratic function, they always ask you to do the same exact thing. They give you 2 points on a parabola, one of them is the vertex, and you're basically supposed to find like a third point. And how you do this is you find the equation of this parabola, and then you substitute whatever x value they tell you to find the y value of this last point. What we can do is we can shortcut that entire process. If we press table, if we enter these 2 points, Desmos will actually do this for us. They'll actually find the equation of this parabola for us. We need to find those 2 points. As I mentioned, they always give you one of them as the vertex. That one's the easy one to find. In this case, the vertex is this, right? The second point is going to be a lot harder to find. It's actually 0, 10 because it was launched from a height of 10 feet. So what they want you to identify is when it was launched, it's at 0 seconds. Make sure we have the 0 and the 33 at the X spot, right? Seconds are an independent variable. They go at the X spot. Otherwise, your equation is going to look really weird. Okay. 33,099 and 010. Put these in. 010. 33,099. Here's what we can do. If we press this add regression button and then switch this to quadratic, we will get the equation of the parabola. The problem is this is not the vertex. Right now, Desmos has graphed 010 as the vertex. So how do we solve this? How do we make sure that the right vertex is graphed? What we can do is use a property of a parabola. It's that parabolas are symmetric around the vertex to find a third mirror point of the 010. So here's what I mean. Whoa. So I just graphed this parabola, how it should look like. 010. Now, any parabola is symmetric along the axis of like the vertex. So this is the line of x equals 33. It's a vertical line, and parabolas are symmetric around that point. So if we have a point at 010, there's another point with a y value of 10 that is mirrored on the other side of the parabola. How do we find the x value? Well, it's pretty simple. If this value is 33 units away from the vertex, if this one is 33 units because the x value is 0 here and the vertex is 33, then this has to be another 33 units away. That's honestly the best way I can explain these mirror points. So if you didn't get it, I'm sorry. Okay. So we just entered the first point and the second point. We were given these points in here. And then this third point is the mirror point, which then makes this the vertex. Desmos has to graph this as the vertex now. Do you see our equation? If we export this, this is our new equation of the parabola. Just replace this with f of x. And the reason why is because we want f of 44. Basically, the question is asking, what is the y value when x is 44? And what we can do is instead of trying to find where, 44 is, we can stop being a barbarian and just do it the civil way. 978. See how Desmos gives you the answer right here? You don't have to look at it from the graph, right? We can use Desmos as a calculator, like a scientific calculator, not just a graphing calculator. We want to learn that. Oh my God, this looks so messy. All right, 978, that's your answer. Perfect. Need to make sure I'm still recording because this is a long video and it would be a shame if I didn't capture the film or it stopped recording for some reason. Let's move on. Right rectangular prism A is similar to right rectangular prism B. The surface area of right rectangular prism A is 75 square inches, and the surface area of right rectangular prism B is 4,800 square inches. The volume of right rectangular prism A is 35 cubic inches. What is the volume in cubic inches of right rectangular prism B? Whenever we see two 3D shapes, there's a 3D shape 1, 3D shape 2, and they're similar. Like the text says that they're similar. This is a scale factor question every single time. We know that these are two 3D shapes because they're rectangular prisms and they're similar, right? So this has to be scale factor. It's going to be a lot easier than the first example that we did at the beginning of this video, which I believe that I explained horribly, but I'm going to explain this one a lot better. To find the scale factor of rectangular prism B to prism A, we need to just simply divide the surface areas first. So what is the surface area of B divided by the surface area of A? 4,800 divided by 75. 64. Now, if the surface area of prism B is 64 times as large as the surface area of prism A, then that means that if we take the square root of this 64, the side lengths of prism B is going to be 8 times as large as the side lengths of prism A. We just have to take the surface area scale factor, or the surface area multiple, and square root that to find the scale factor. The scale factor, the definition of scale factor is how many times larger the sides of the larger shape is to the smaller shape. So if the scale factor is 8, that means that the volume of prism B divided by the volume of prism A is going to be the scale factor cubed. What is that? 8 to the power of 3, 512. So we know that prism A is 35. So we can actually replace this with 35. So we get the volume of prism B if we solve for this, like if we isolate volume of prism B, then we get this. Volume of prism B equals 17920. Okay, perfect. Let's move on. X times 3k minus 11 plus 25 equals 37x plus 60. In the given equation, k is a positive integer. If the given equation has exactly one solution, what cannot be the value of k? All right, you can totally try to solve for k here by simplifying everything down, and um, there's a faster way. There's the easier way too, and they're both the same way. So here's the faster and easier way. It's just by thinking about it a little bit. Anytime you are given a number of solutions on the SAT, it's either involves discriminant or slope. The way that you know if it's discriminant or slope is if there's a parabola. In this system of equations, because we can treat these as system of equations, like each side of the equation, this one is not a parabola because it's x to the power 1, y to the, there's no y. This one is also not a parabola because it's x to the power 1. These are both lines. And since it's lines, we have to always just set the slopes equal to each other. Whenever we see solutions and they're both lines, we just set the slopes equal to each other. It just always works. If there was a parabola, then we would have to do discriminant, and I think there's a question about that later in the video. So we take the slope of the first line right here. The slope does not have x in it, and it does not contain like the y-intercept at all. So what do you think the slope is of this line? 3k minus 11. It does not have x in it. So this is not the slope. This would be wrong. Don't do that. And this is equal to 37 because this 37 is the slope of the second line. Okay, let's put this into Desmos. 3k minus 11, 37. And if you think about it, the reason why we're setting these slopes equal to each other in the first place is because when two lines have the same slope, they're either parallel, which means they have no solutions, or they are the same line and they have infinitely many solutions. So if k is 16, it's either these two lines are parallel or infinitely many solutions, and they're not one solution. Is this what cannot be the value of k? The answer is what we got. A certain town has an area of 6.25 square miles. Which of the following is the closest to the area in square yards of this town? 1 mile equals 1,760 yards. What do we want to do here? A lot of you guys know what dimensional analysis is from chemistry. So you guys do that thing where it's like 6.25 square miles, and then you convert the units like 1760 yards over 1 mile. You cross out the units. In this case, we can't exactly do that, and I'll show you why in a second. But you can definitely do this dimensional analysis method for this problem. So if you know that, then do it. But for the students that don't know what that is or have never taken chemistry, that's fine. We don't need to. There's a way that's a little simpler that a lot of students have an easier time grasping. So this is the method. First of all, anytime you see like a parentheses and like this is equal to this on the SAT, like 1 inch is equal to 2.54 centimeters or something, this is always going to be a unit conversion question. So like immediately stop what you're doing, unit conversion, get that into your like, I guess just stop looking for what type of question this is. You already know what it is because you see this parentheses stuff. So write it out. That's the first part of this method. The second part of this method is to write out the end units that we want and give yourself a little bit of space because we're going to work here. So 6.25 square miles. Square miles and miles squared are the exact same thing. And then this is equal to something. You can put a question mark here, or just put a placeholder. What we want to do is we're not allowed to touch this right now, like at all. We can only manipulate this ratio or this equation to look like this. So let's say we multiply by 6.25. This is actually not what we want to do because then we end up with 6.25 miles, but we need miles squared. So what we want to do first is we want to square both sides. And when you square something, the square distributes. That's just an exponent rule. So 1 squared miles squared equals 1760 squared yards squared. Whoa. And then this turns into 1 because 1 squared is 1. Now, if we want to turn this into this, now we multiply by 6.25. And do you see why we didn't do that earlier? Because if we multiplied by 6.25 first and then squared it, then it would be the square of 6.25. It just wouldn't work. We'd have to multiply by the square root of 6.25. Just square first, then multiply the number. Okay, so we multiplied this to both sides and make sure that these two that you end up with match so that this question mark is equal to whatever this is because you got the correct ratio. Oh, did I drop a squared? What am I doing? Okay, there we go. There should be a squared there. 1760 squared. And we notice that that's D. It's a very big number, but it's correct. Okay, let's move on. In the given system of equations, P is a constant. The graphs of the equations in the given system intersect at exactly one point, xy in the xy plane. Which of the following could be the value of x? Do you remember what I said about solutions when it gives you the number of solutions? Intersections also count as solutions. If two like if two functions intersect at one point, that means they have one solution, right? So what did I say about solutions? It's either discriminant or you said the slopes equal to each other. M1 equals M2. How do we know if it's discriminant or slopes? We check if there's a parabola. If there's even one parabola, then it has to be discriminant. In this case, it's going to be discriminant because when we set the two equal to each other, I mean, there is a definite parabola here because it's x squared and not just x to the power 1. So here's what we need to do. We need to set these equal to each other, and then let's move this over. I did a couple steps in one, but I just basically minus px to the other side and 10 at the same time. That's all. Okay. Now, since I like positive numbers, I'm just going to multiply both sides by -1. There we go. And now we use discriminant b squared minus 4ac. And this has to be, which could be the value of x. My bad. Intersect at one point. This is what we did. So we set b squared minus 4ac equal to 0. When a parabola has one solution, we set b squared minus 4ac equal to 0. B is equal to P. Why am I using my eraser right now? Okay. B is equal to P. A is 2. C is 50. Equal to 0. Okay. P squared minus 4 to 50. And then instead of the equal sign, let's use a tilde. We get P is equal to 20. Now, in reality, P is equal to plus or minus 20. Now, here's the thing. This is a little bit of an advanced trick, but when you're using tilde and you have multiple solutions like you do here, tilde doesn't actually show you both solutions or all of the solutions. It only shows you one. That's an issue. What you can do to fix it is just change this back to x. But what also I like doing is I like setting a domain. If P has to be less than 20, then it will find the other solution. In this case, the question will always hint that there is multiple solutions. In this case, which of the following could be the value is the part that gives it away. So just be very careful when you're reading the last sentence of any SAT question. The last sentence usually gives you a lot of hints. And whenever you're dealing with parabolas, make sure you're checking that there aren't two solutions. If there are, just mark them, right? Okay. Let's actually get back to doing this question. 2x squared. A lot of you might have marked 20 and moved on. This would be the wrong answer because x is not 20. P is 20. So let's read the question, please. 20x plus 10. Okay. Oh, by the way, do you see how I use that home button right here to go back? You can always do that. Press the minus button a couple times. And do you see how when you click one of the graphs, their intersection points illuminate? So just click one of the graphs and then export the point. Let me show you how to export the point. If you don't know, there we go. -5, -90. which of the following could be the value of x? So it's B, -5. It is not 20. Now, if we tried -20, we'd still get 5. So I get, whoa. Oh, yeah. We'd get, it's been a long day today. Okay. So it would either be plus or -5 for the value of x. Just make sure you're reading very carefully. That's all. In the given system of equations, m is a constant. If the system has no solution, what is the value of m? Again, whenever we get a question, and it shows us the number of solutions, we're typically either setting the slopes equal to each other or using discriminant. Which one do you think it's going to be? Well, if you look at these, there's no x squared in any of them. If there was a single parabola in this system, then we would have to use discriminant. But there is no parabola. All of it is x to the power 1 and y to the power 1, meaning they're both lines. All right. We're basically just setting the slopes equal to each other. That's it. Now, what we could do is we could graph both of these and then make a slider for m. But I've seen so many students spend like 5 minutes trying to do all the slider stuff. So just do this by hand. What you can do is since anytime we're given the number of solutions and we know that it's a slopes question because there are no parabolas, we are just setting the slopes equal to each other. So you can ignore all of the constants actually. They just don't matter. So 2/5 x equals negative. Oh, I skipped a couple steps. Let me show the steps for you guys. Then when you subtract thirds y to both sides, you get 2/5 x equals -8 over 3y. Then from here, you just isolate for y. So -3/8. And then this can be 4. Oh, 4. -3 over 20 equals y. Oh, x equals y. Perfect. So this is our simplified first equation without the constants. We don't need the constants because we're just setting the slopes equal to each other. The second equation is going to be 7/6 x equals my. If we divide m to both sides, anytime we divide by something, we're just multiplying by its reciprocal. So dividing by m is the same thing as multiplying by 1 over m. Okay. So really y is just equal to 7 over 6m x. Okay. These are our two equations without the constants. We don't need them. We're going to set these slopes equal to each other because that's what we do every single time we see an equation or a question that gives us the amount of solutions and both parts of the system are lines. I'm going to keep repeating that until we get that. So when I set the two slopes equal to each other, the slopes never have x in them. I'm just going to put it into Desmos. And then here, this is the cool part. I don't know if I've showed you this in this video, but what we can do is on a new line, just type in m because it's already saved, like the number, right? It's saved right here. And then press this fraction button on the left. So m is equal to exactly negative 70 over 9. And that's what we're trying to find, the value of m. Yeah. Last few questions here. So let's get through these. I'm still recording. Perfect. Perfect. Let's keep going. Sphere A has a radius of 6x, and sphere B has a radius of 114x. The volume of sphere B is how many times the volume of sphere A? How many times? This is a scale factor question. We've done two of these today. I made the mistake of putting the easiest one last. I should have probably put the easiest one first. And I put the hardest one first, actually. So I don't know what I was thinking. Let's do 114 divided by 6. This is equal to 19. That means that the radius of sphere B is 19 times larger. Yep. How many times larger is the volume? Now, 19 is actually our scale factor. This is how many times larger basically the radius is. The scale factor cubed represents how many times larger the volume of sphere B will be compared to sphere A. These are a scale factor for the side lengths. Now, this cubed is our answer. 6859. The scale factor cubed is basically volume of sphere B divided by volume of sphere A. Because this is basically the radius of sphere A divided by the radius of sphere B. If the radius of sphere A, if the radius of sphere B divided by the radius of sphere A is 19, then the surface area of sphere B divided by the surface area of sphere A will be 19 squared, and the volume of sphere B divided by the volume of sphere A will be 19 cubed times larger. Next one. No idea why this one is in bold. The function g of x equals square root of 6x plus 20. If g of a equals negative 6a, where a is a constant, what is the value of a? G of x equals square root 6x plus 20. Here's what we want to do. This is really simple. This is the fastest way to do it. Or I guess this is the easiest way to do it. The fastest way would be, if you're really good at math by hand, I guess you could do it by hand. And this, if you know your fractions, it's negative 2/3. But if you don't know your fractions, that's totally fine as well, because you can just type a and this fraction button. So type the variable, type the fraction button. We just replaced the equal sign for tilde. That's how we do this wrong. So anytime you're given a function and you're told to solve for a value of x, when you're given the value of y, even if the value of y is in terms of the variable, right? You can still solve for a. Desmos does it for you. I have no idea why it is allowed on the SAT, but use it for as long as it is. All right. We're down to the last two, right? Is there anything left? No. Are you ready? This is the final countdown. Okay, still recording. Perfect. Let's keep going. The quadratic function ax squared plus 160x plus c has at least one real solution. What is the greatest possible value of AC? If you ever see greatest possible value of AC, there's a formula. I mean, you just use discriminant. If you ever see what is the greatest possible value of B, there's a formula, AC plus 1. They will never ask you for the least possible value of AC. They will never ask you for the least possible value of B. I've just never seen it. And yeah, the SAT doesn't really ask you questions that they've. Let me put it this way. I'm an SAT tutor. I see a lot of SAT questions. I've never seen least possible value of AC or least possible value of B. And I've seen these questions a lot, where it's greatest possible value of AC, greatest possible value of B. The SAT loves repeating their hard questions. They just switch up the numbers every single test. Okay. We want to use discriminant for this question, so it's pretty simple. B squared minus 4AC. That's what the discriminant is. And since it says at least one real solution, remember number of solutions, we use discriminant if it's a parabola. All we want to do is we cannot set this equal to 0, and we cannot say it's greater than 0 either. Because if it says at least one real solution, it can be 0 or 1 solutions. I mean, what am I saying? It can either be 1 or 2 real solutions. I'm going to draw this out just to make it real for you. So this is a parabola with one real solution. And if it says the parabola can have at least one real solution, then it can either be this or 2 solutions like this. So it has to be greater than or equal to 0. Because it can be both. So then we start plugging in everything. We're only looking for the greatest possible value of AC. So we don't care what A and C are individually. For AC is less than or equal to 160 squared. So we can divide the 4 to the other side. I'm just skipping a bunch of steps when it comes to the math because I think, well, I know that you know the algebra. So I think explaining the concept better is definitely more important. Okay. So in this case, the answer is 6,400 because what is the greatest possible value? And since it can be equal to, it's going to be 6,400. If it said something like, instead of at least one real solution, it said it has one real solution, then this would be equal to 0. If it said it has 2 real solutions, then this would be greater than 0. And this would end up as AC is less than 6,400. So the answer, if it said 2 real solutions, would be 6,399. But since it says at least one real solution, we add these equal to signs back. 6,400. That's our answer. Okay. I'm normally pretty introverted, so I don't talk this much ever. My my throat is like parched. I'm losing my voice, but I'm actually enjoying this a lot. So I might just keep doing these videos as long as they're helpful for you guys. So yeah. Okay. So the formula for this is just AC plus 1 whenever you see greatest possible value of B and you're not given and you're given A and C, just do this. AC plus 1. Again, you don't need to know why it works. You just need to know that it works. 30 times 48 plus 1. But then you'll be like, Roy, this doesn't even look like a parabola. How do you know that we can take the A and C value like that? Because it's not in x squared form. Well, here's the thing. If we take x equals r to the power 8, and if we set x equal to r to the power 8, and we square both sides, what we're going to end up with is x squared equals r to the 16th. And if we replace this with x's now, we get 30 x squared plus bx plus 48. This is a quadratic, right? And instead of, this part is irrelevant anyways, but the new factor would be px plus c. So we're just trying to find a normal factor of a quadratic. Or at least, sorry, the greatest possible value of b. We're not looking for a factor. Now the greatest possible value of b is always going to be ac plus 1. 30 times 48. 30 times 48 plus 1. So just memorize this formula. You use it anytime you see what is the greatest possible value of b. And whenever you see what is the greatest possible value of AC, you use discriminant. Okay. That was awesome, actually. Let me end this recording and then I have a couple words. The last thing I want to say is that for any of the parents watching, if you want private one-on-one SAT math tutoring for your child, go to thesatmath.com and sign up for a private one-on-one tutoring session with me. On that website, you'll also be able to see some of the student results from the most recent SAT. Now, here's the thing. If you go to the student results and if you scroll through them, you'll see that I actually don't have a lot of students that started scoring in the 500s or 600s on the SAT math. Now, the reason why is because I honestly just didn't get a chance to work with them in June, basically the most recent SAT. But I'm currently working with a couple students that started at the 500 and 600 range on the SAT math, and they've improved significantly. Basically, what I'm saying is if your child is currently scoring in the 500s or 600s on the SAT math, I want to work with you. I just didn't get a chance to this last round because most of the students that signed up were already at the 700 range. And for all the students, I'm rooting for you. Awesome work today.